Today's video, we're going to talk about measures of skewness. When we talk about measures of skewness, it describes the degree of the departure of the scores from symmetry. In skewness, it can be classified according to the skewness coefficient. For example, if skewness is greater than 0, it is called positively skewed. So here. However, when we talk about skewness is less than 0, it is negatively skewed. And if skewness is equal to 0, the scores are normally distributed. So the skewness of the score distribution indicates only the performance of the students, but not the reason about their performance. So, we have two types of skewness just like what we have told. We have the positively skewed or skewed to the right distribution. So, distribution tapers more to the right than to the left. And it has a longer tail to the right compared to a much shorter left tail. And also, values are more concentrated below than above the mean, and they also have large values in the right tail, and it is not offset by correspondingly low values in the left tail, and consequently the mean will be greater than the median. So this is an example of a skewed to the right distribution where the thin end tail of the graph goes to the right part of the curve. So this happens when most of the scores of the students are below the mean. Next one, we also have the negatively skewed or skewed to the left distribution. So the distribution tapers more to the left than to the right. It has longer tail to the left compared to a much shorter right tail. It also more concentrated above than below the mean, and small values in the left tail will make the mean less than the median. So here is the example of skewed to the left distribution or the negatively skewed, wherein we could see here the distribution where the thin end tail of the graph goes to the left part of the curve. So this happens when most of the scores of the students are above the mean. So in skewness, we have this coefficient Sk can be solved using the formula. So we have here the mean minus mode over S, where S is our standard deviation. We also have another formula wherein we have skewness is equal to 3, multiply it by the quantity of mean minus median over standard deviation. So take note, since the mode is frequently only an approximation, formula 2 is preferred. So in interpretation of the measure of skewness, if skewness is greater than 0, so this is a positively skewed. Next one is if the skewness is less than 0, it is negative. So we have here an example wherein we will be computing the skewness of the distribution. So given the following statistics on weight, mean the performance of the first-year college student in their mathematics in the modern world, we have mean is equal to 74.1. Median is equal to 75, mode is equal to 84, and standard deviation is equal to 11.25. So using the first formula, so we have skewness is equal to 74.1. So that is the mean minus our mode, so that is 84 over 11.25. If we will compute this one, we will get negative 0.88. And the result is, it is skewed to the left, or it has negatively skewed distribution. Next one, if we will be using the second formula, so we have skewness is equal to 3, multiply it by 74.1 minus 75 over 11.25, we will get negative 0.24. It is also skewed to the left. Skewed to the left. So if this will be the result, it means that perform the students who took the examination perform well. So with this, we could associate that the possible reason why students get a high score because they are smart, or they have enough time to finish the examination, that does items easy, or there is an effective instruction and the students have prepared themselves for the examination. So that could be the possible reason. So that's all. Thank you for watching.